Now the next section making facility is called hypermodels, which is new in SS3 and later. Hypermodels take the place-fitted sections concept one step further and allow you to dynamically switch between 3D design models and 3D sheet models. It uses a system of markers, which are visible in both the design and sheet models, together with mini toolbars, which are attached to the markers. Now, this is very much a high production tool, and it can be very confusing at first glance. So the information I'm giving you here is a very basic introduction to hypermodels. And as you can see, I'm going to continue using the bushing model. Now, you might want to make a clean bushing design file before you start, because you'll be creating multiple sheet views and save views. Now, for my purposes, I have a standard default model, which contains the bushing element. And I made a copy of that. So I'm using and working in this basic bushing design, which is just a copy of the original default model. I'm using the default as a backup if you wish. Now we're looking at wireframe right now, but wireframe does have some colors attached to it. And if we open up view attributes and look at the settings for that, you'll see that for the cut, I have the same blue that I had previously. And for forward, I have the same green that I had before. And in both cases, hidden edges is on. So I can dismiss that and dismiss that. Now the hypermodel sections are driven by the detailing symbols tools. And we need to go to tools and look for detailing symbols and float the toolbox. There it is. And here we see a collection of different tools. If you look carefully, you'll see that the first four, these are called callouts. In this case is place section callout, a detail callout, an elevation callout, and a plan callout. The last three tools here, placing drawing titles, title text, and clouds. We won't be dealing with those too much. We're only interested in this place section callout for our purposes. So I'm going to start with that tool. And let's take a look at the tool settings window. The first selection here is called the drawing seed. It defines the seed file for the detailing symbol and the actual symbol style. Also, the drawing seed selection determines whether a dynamic sheet model, a dynamic drawing model, or no models at all are automatically created. Now, for our purposes again, we'll stick with the default, the section English C, although you can use a metric equivalent if you wish. Next thing is the height. We want this to be from model, but check the help files for the other two values here. I don't want to get too deeply into this, so just make that from model. And create drawing should be on, which will cause the automatic creation of the dynamic views. So let's place the section. I'm going to do that in the top view, so I'm going to just reduce this in size a little bit. And what we do, we look at the prompts. It says define start point for the callout. I'm going to data point just above the center line here and drag downwards. And you see that I'm dragging a section line. I'll drop it right there. So I let go. And now I drag the extent of the section. In other words, the volume that will be included within the section. Then I data point to stop the process. The section is in place and the create drawing dialog box displays. Automatic name is section, but we can change that to vertical section. The drawing seed, as we know, is the section C English. It's a section view, we know that. Discipline and purpose, we can actually change these in a different place, but they simply define what kind of drawing we're creating. Now here we have create drawing model on. Now you might think this is odd because we are already in a drawing model, but this will create a separate one as you'll see. We're using a seed model for this, which again is the default, so leave that as it is. But all of these seed models you can change or create your own if necessary. Now if we turn this off, note that this also turns off. So this becomes blank at the bottom. We need that on. So we automatically create a drawing model, and I want to create a sheet model too. Now the annotation scale, I'm going to change to full size. And this is simply because I'm working in a model which is pretty small. It's only 11 inches long, so I don't really need a scale at this point. But you can have a scale, especially for larger drawings, obviously. Same thing for here, full size for that, and full size for that too. Last thing, make sheet coincident. We can leave that off for the moment. and tick mark for Open Model, meaning that when we create this model, it will automatically open in that model. Everything's set, so we'll say OK. So the vertical section sheet model displays, and it shows the vertical section of the bushing together with a call out beneath the section, which is this, and that can be edited in place, and a symbol at the top left here. Now we'll talk about this in detail a little bit later. And we also see, of course, the sheet boundary, which was set in the defaults in that settings box that we just dismissed. If you actually zoom into this call out, you'll see that we have the name of the section automatically placed. The size is 1:1. We set full size, and we can edit any of these pieces of text. Now, the last thing to do is to have a look at the models dialog box. And here we see my basic bushing, which I was already in, but 2 new sheets have been created automatically. This is the vertical section, which is what we're looking at right now on the screen, but a drawing model has also been created. Now, I'm not going to get deeply into drawing models at all, but just keep in mind that this is where you would place text or other recurring information, which can be referenced to other sheets. It typically saves having to repeat information on separate sheets. So that's where I'm going to stop for the moment. In the next video, I'll start delving deeply into what we're actually seeing here.